Ready. Ready. Ready.
Hello. Welcome to Enlightening. I'm so glad you're here. Thanks for joining us today. I'm here with Stevie, who's going to teach us about Goldilocks. Stevie, will you introduce yourself, please?
I will. My name is Stevie Caldwell, and I work at Fairwinds. I've been there for about 5 years. I'm a senior SRE tech lead, and I, work in Kubernetes. That's what Fairwinds does. We build and maintain and harden clusters, and I also write a little bit of Go on the side.
A little bit of Go on the side. I'm going to put you on the spot. Do you have a joke handy?
I will repeat one that I used in a webinar that I did yesterday.
Okay.
Why do astronauts like computers so much?
Why?
Because they have space bars.
What the da?
Uh-huh.
Mine are all like kind of dark compared. Like I like my favorite one right now is what's red and bad for your teeth?
What?
A brick.
Yeah. It's dark. Violence. No, that's a good one though. And I will be using it. So thank you.
All right. Epic tra-la-la. You made it on time today. Thanks for coming, friend. So glad you're here. Let's get started. Let's get down to business. We can. I'll come up with another joke to tell again at the end for those of us. People are going to be like, I'm definitely not staying till the end.
Like, please no more. Mercy.
How soon do I have to end it to avoid this joke? So let's dig right in on the tech stuff. So Goldilocks, what problem existed in the world that caused Goldilocks to get created?
Well, in the long ago, in the before times, it was the wild, wild west in terms of, I'm going to say it's a wild, wild west, probably not really for everybody, but the problem that existed was that people maybe didn't really understand the role that resource requests and limits played in your workload and how your workload performed in a Kubernetes cluster. And sort of took, one of two routes, right? Like either didn't set any resource requests or limits, or sort of copy pasted, things from like examples that they've seen on the Kubernetes docs site or something into their manifest, which obviously weren't tailored to what their workloads actually needed. And so, what could happen in both those cases, right? If you don't set anything, then you're essentially letting your workloads fight it out on the node for resources, which can cause, resource contention on the node and can cause instability in how your workloads perform. And it lacks any kind of predictability in understanding what, you need for your resource or for your workloads, right?
I would like you to repeat those three things.
Oh, I'm
Please.
sorry. Yes.
No, don't apologize. Don't apologize. I just got really into the fight it out imagery and like.
You're thinking of bricks again?
Apparently, I'm very violent deep inside. So resources would fight it out, and you rattled off 3 things that made this bad. Well, first, paint me a picture, and I'm probably not going to put this on the board, but like, what did it mean that resources would fight it out? Like, kind of like whichever ones happened to be scheduled on that node first got priority, whether or not they were really should have priority, or what does fight it out mean?
So it essentially means that like you could have a container that is maybe like maybe your application has a memory leak, or maybe one container, one pod is getting a lot more traffic than other pods, so it tries to consume an increasing amount of resources on the node, and then other pods don't have access to what they need. And then you have this whole thing that starts happening with, maybe then the node becomes under resource contention because the actual underlying like CPU and memory starts to get, drained. This is the word I'm going to use, but just consumed. And then you might start having things like your pods getting evicted, your containers being killed, things like that. So it's not great. It's not great. It's very, so it introduces potential for instability in your work. And then it also does not, it decreases predictability for how your workloads will perform under, different load. So, if you have peaks during the day, during the business day or something like that, like it's unpredictable how your workloads are going to perform because you don't know what you don't know.
You don't know. That's everything.
That's everything.
Doing like a whole series on observability, and it all kind of comes down to that.
Mm-hmm.
I have 2 things to say. One is, when you said killed, it made me realize I've only ever read OOM like out of memory, and I've never heard it spoken, and I would never have thought, I don't know that people say killed. It's like, oh.
It's a very weird word. Yeah, for sure.
I love it. And number 2 is, one thing I'm surprised you're not saying right now is like how expensive it would be if you did have one that had a memory leak and that was able to get away with it. So you're talking about performance problems and instability, and these things are important, surely. But I thought maybe the cost of it, like just the sheer expense of it, would weigh in.
Yeah, I mean that could be a factor as well. If you have auto scaling underneath the hood, so then you have more nodes being spun up to potentially accommodate the increased resources that your workload is asking for. That definitely contributes to a cost increase too.
But is it like is it worth putting on the board?
Sure. Yeah.
Is it that?
Put it on there.
Yeah. Cost increase. Yeah. So anytime there are inefficiencies, I suppose that means a cost increase.
Potentially,
and anytime
yeah.
there are inefficiencies at scale, then it's like substantial something. Do you think we captured the before times? I have one more question.
Yes.
After you answer the one I already asked.
Well, so the other, what did we say? Request limits underutilized and or misused. Yeah. So we either don't set any or we set them incorrectly. So then we are giving our workloads too little, which causes them to underperform. Or we're giving them too much, which that also directly ties into a cost thing. Because if you're saying I need some amount of memory or CPU, the scheduler is going to take that into consideration when it schedules your node, your pod, or your workload rather. And if there aren't nodes available, like if it doesn't think there are nodes available that can handle that, it spins up more nodes. Your autoscaler will spin up more nodes as a result of those pods being in a pending state, right? And so if you've overestimated how much your pod needs, and you say, I need 256, megabytes of memory, and there for some reason is a node that doesn't have that, a new node will get spun up, and then just because you request that amount doesn't mean your pod even starts off using that amount, right? So it can start off using less, and now you've got all this extra wasted space on this node because you overestimated how much your pod needed.
So wasted space on nodes, and then also if you give it too much, that's when you have the noisy neighbor problem that you were saying, the bullies, when they fight it out, the bully ones.
Right.
Yeah.
Right.
Nick's here. Nick would like to know what we're talking about today.
Hi, Nick.
Hi, Nick. Welcome.
We're talking about Goldilocks, which is an open source software that helps you visualize resource requests, suggested resource requests and limits, and gives you a good starting place for setting those in your workloads.
Awesome. Thanks for being here, Nick. Nick's a regular watcher. So I recently got laid off from VMware Tanzu, and so I used to stream these on the VMware Tanzu channel, and now they're being streamed on my personal. And so Nick is a regular watcher of the show, and just figured out I'm still doing it over here in my corner. So nice. I'm so glad you found me, Nick, and I'm so glad you're here. And then the other question I was going to ask you is about when was Goldilocks created? So when we're talking about these before times, when are we talking about exactly?
So we're talking, I could look at the repo and tell you the date of the first commit, but generally about 5 years ago. So my CTO, Andy Suderman, started roughly before me, and that was one of the things that he started working on when he joined Fairwinds, was creating this tool because he saw a need. He's very passionate about setting resource requests and limits.
I'm glad someone is.
Yes, it's a drum he's been beating for years, and so Goldilocks was a result of that.
It's a great name. I love it.
Yeah, I didn't know. Just a little piece of trivia: when I hear Goldilocks, I think of Goldilocks and the Three Bears, right? Which totally fits just right. Yeah. But also, there's apparently an astronomy concept called Goldilocks related to a Goldilocks zone, which is something having to do with a planet or a place in space that is perfect for life, for being inhabited. So and that's what they actually that's what he actually meant when he first when it was named, I think, because Fairwinds had a sort of space theme for a lot of our open source: Nova, Pluto, Polaris, Goldilocks. So
that's sweet that he thought that people might think of it that way instead of us, the bears.
Instead of the three
bears. Right. So I want to know the big, what is Goldilocks? Let's get that on the board.
Yeah.
Level set. Yeah.
Goldilocks is a visualizer for resource requests and limits. Recommendations.
For Kubernetes specific? Can I say Kubernetes?
For Kubernetes specific, yeah. For Kubernetes resource recommendations. Say that.
Is it do something besides requests and limits?
No,
is it advising you about node size or?
No, it is strictly telling you or giving you a starting point for where to set your request and limits for CPU and memory.
Okay, so I would Kubernetes resource. I would like to include that in the definition, please, if that's okay.
Absolutely. It is your hand doing all the writing.
And you're the expert, so I shouldn't be telling you what it is. It's a team effort.
It's a team effort.
Goldilocks is a visualizer for Kubernetes resource requests and limits. Is that good, or was there more?
I think that'll do it. I think that's a very succinct definition for Goldilocks.
All right. So I'm sure we'll dig into it. And
Yeah.
Nick has let's hear what Nick has to say. Nick, misquote a lot of the times your streams are at the same time with meetings. Oh, it happens that way since I do it in the business day. They're insightful. Thank you, Nick. So where can one use Goldilocks? Is it Kubernetes specific, which I think we were just talking about? It is Kubernetes specific.
It is, yes.
Yes.
Yes. So it's Kubernetes specific. You can use it in your Kubernetes cluster. It can be deployed as a Helm chart, and it runs a controller in your cluster. That, I mean, we can talk about the sort of rough architecture and how Goldilocks works, if it's time to get into that.
It's deployed as a Helm chart and run as a controller instead of CRDs, probably.
That is correct. Yeah.
Cool. I think you kind of said this is succinct, and you were kind of implying there's a lot more to it. So I think before we get into like the how it works and the architecture of it, I think I would prefer to learn more about the functionality.
Yeah.
And then later about how it works, if that's okay.
Yeah. So when I say that's, I mean, so Goldilocks is, it provides a dashboard, right? So you run this controller in your cluster. It interacts actually with another underlying technology called the vertical pod autoscaler, and takes fields from that, from the vertical pod autoscaler status and displays those in a way that provides the user with recommendations for each pod, each container in the pod. So it uses the information from the VPA to display a recommended starting point, so request for your memory and your CPU, and a recommended endpoint or limit for memory and CPU. And it does this, and it also separates those into two different QoS families for Kubernetes. So those are quality of service.
Okay.
And
you're getting a little bit ahead of me.
I'm sorry.
If that's okay. It's
Yeah,
okay.
no.
It's a different format of a show because I have to write and process and
I will slow down. Sorry.
Great chat interaction. Once we have Emily here. Hi, Emily. I'm glad you made it again. Emily's excited for this topic. Setting proper request limits has been quite challenging since some pods have big spikes on startup and other times potentially when they hit a lot of traffic.
Yeah.
So, and so Emily, I'm about to ask about the vertical pod autoscaler. She's been thinking we could benefit from vertical pod autoscaler, but haven't pursued it much yet.
Sure.
So before you started to say how Goldilocks interacts with vertical pod autoscaler to make these recommendations, but I think I need to slow down and talk about what vertical pod autoscaler is.
Yeah.
Because I honestly was very familiar with the horizontal pod autoscaler, but I didn't even know before today that there was a vertical pod autoscaler. Is it a part of Kubernetes, like built into Kubernetes?
It is not built in. You do have to install it.
Okay.
And so it installs its own set of CRDs, custom resource definitions, as well. And let's see. So VPA essentially has three parts to it.
Okay.
So there's a thing called the recommender.
Okay.
And the recommender takes metrics that it gets from some endpoint, and that can be metric server by default.
Okay.
Or you can set up Prometheus and get metrics from there. And it uses those metrics to essentially make a recommendation for what it thinks your pod should be set to for your request and your limits, right? And then it passes. Then it interacts with the other component, which is called the updater.
Okay.
And the updater is then responsible for evicting pods that don't fall within the range that the recommender said it should, right? So essentially, if the recommender says, yeah, I think this pod needs to have this amount of CPU requested and this amount of CPU as a limit, and the pod doesn't have enough. Like if the pod has consistently been if the pod doesn't have enough of a limit already set in its manifest, then the pod will be evicted because I think this has changed with 1.28, but pod specs are immutable. So in order to change a pod, you have to delete it and redeploy it, right? So the updater would be responsible for trying to evict that pod, delete that pod, and then the controller for that pod, so the stateful set or the deployment, will obviously notice that there are fewer replicas than it's supposed to have and try and create a new pod. And then that's where the third piece of the VPA, which is an admission controller, comes into play.
Hold on.
Mm-hmm.
Thank you. The third one is, we got recommender updater, and the third one,
admission controller.
Admission controller.
Yeah.
So my question, so basically you're asking the vertical pod autoscaler to make recommendations, and then you're trusting what it recommends so much that you're letting it evict stuff that falls out of the...
Well, that's part of the setup. So there's a flag called update mode, and you can set it to 3 different settings, right? You can set it to auto, which then it will do this.
You do trust it, okay?
Yes. Or you could set it to
Probably
I think
audits. Yeah.
There's one that's initial, where it only sets it during the very first deployment of the pod, and then there's the one that we use, which is just off. So it does not actually affect the pods at all. It essentially just uses the recommender portion of the VPA.
Okay.
And that's what Goldilocks. So if you install, so Goldilocks relies on the VPA, right? And our chart, you can install it as a subchart of the Goldilocks chart. And if you do that, we set it to disabled. Update mode is set to disabled by default because we only want to use the recommender by default in Goldilocks.
Through Goldilocks, can you turn on the other stuff if you want to?
Yes, you can.
Okay.
And then, so the other option is you can install the VPA yourself, right?
Okay.
And then you can also twist probably more knobs than we expose in our chart. But you can also install it yourself and manage whether or not you want the auto update mode to function.
Cool.
Yeah.
Okay, so admission. So we have a recommender, and then the updater, and then the admission controller.
Right. So the admission controller, if you have it set to update mode auto, when the new pod is created, the admission controller will mutate that pod and set the request and limits according to what the recommender said.
Wow, it has so much power.
It does. It does. And with that power, that means there's some risk, especially because I think I don't know if I finished the thought, but prior to 1.28, I think I read that in 1.28 of Kubernetes, the pod spec, the resources can be changed live, so it doesn't require deleting a pod. But I'm not sure if VPA has implemented that yet. But the fact of the matter is that, in order to have the VPA change your pod requests and limits for you, it has to delete the pod, right? And so
Mhm.
that can that can make people a little nervous, especially if you don't have like proper pod disruption budgets set or something like that. Folks don't necessarily, I mean, it technically shouldn't, right? Because one of the whole purposes of Kubernetes is that you're running these sort of workloads that can withstand that kind of disruption, because pods are getting, scheduled all over the place, your cluster scales, and Kubernetes does that for you. But, it still makes, and I understand it can still make people like a little nervous to have their workloads just being, changed without
Yeah.
their knowledge. It does also like potentially cause some conflicts if you're using GitOps, right? If you have something like Argo installed, then that could
Argo's
be
gonna fight the VPA to they both want different states.
Exactly.
They're gonna fight it out.
They're gonna fight it out. We're always coming back to that. And you also it can VPA if in auto update mode can also have conflicts with the HPA, which you're familiar with, right? Because they will oftentimes scale on the same metrics, right? HPA by default, most people will use CPU and memory for scaling, and VPA is using the same metrics, so that can also cause some conflict. They can also fight it out.
VPA is a brute that likes to fight.
It is. But it's very smart, very powerful, and very useful.
Ain't that how it is with the folks that like to fight? GitOps, HPA, SREs.
Right.
That's it. Yeah. And in general, I mean, it's kind of a pie in the sky lofty thing, but I've heard like a purist mentality would be like you want your desired state to be captured in GitOps, and you don't really want mutations to happen with any admission controller. Like the ideal thing is to have your desired state in GitOps in the first place, so it's not being mutated as it's created.
Yeah.
There's some things you can't know until runtime, so it's not. I don't know how realistic it is, but I've definitely heard that point of view.
Yeah.
So this is very helpful. So now with this background knowledge, Goldilocks is a visualizer. And so I can understand now it uses the recommender to recommend in a dashboard format, recommend what would be good requests and limits for your pods. Right. And then does it do stuff beyond showing you recommendations in a visualizer?
It is purely there to make it easier for you to see what the recommender says, so that then you can go and make appropriate changes and start off in your code, in your infrastructure as code, right? Because we tell people, developers all the time, you need to set resource requests and limits. And where do you start with that? Right.
Yeah.
And like I said, earlier, most folks are going to start with some copy pasta from, some example that they found online, or they're going to make a guess. And at least with this way, this is coming from like actual data. So one thing that I think I may have left off in the VPA section, right, is that the way the VPA exposes these resource recommendations is through a CRD of its own, which is the VPA itself, right? So if you go into a cluster, you can go, kubectl get VPA, and then and that's the object that you would have to create manually. That's the object you would have to create manually to make use of the VPA. So if you just install the VPA, nothing's going to happen. You would actually have to, for every workload that you want to be controlled by this or to get the information for, you need to create a VPA object and specify, the deployment controller or stateful set controller name, or and things like that, to get the VPA to start making recommendations for that thing, right? So that's how that works. And so Goldilocks, actually, I think I lied a little. It's not just a visualizer. Because it
It's
actually
exciting this way.
this is great. I keep you guessing. It actually does create those VPA objects for you. So it
Okay.
saves you the trouble of having to manually create those objects.
Okay.
Yeah.
And they're called like visual pod autoscaler
Mhm.
objects. Okay.
Yeah. Yeah. So they're actually things, you can see them in the cluster. They show you, they have a status section that shows you what the recommender is recommending. And there's like 4 different categories, like an upper bound and a lower bound and things like that.
So it's called vertical pod autoscaler, right?
Yeah.
Okay. And it's a object. It's an object that gives Kubernetes permission to do these things.
It's an object that lets you set some flags for how you want the VPA to work, and also shows you what the current recommendation is.
Okay.
Yeah.
For how configure how you want VPA to work.
Mm-hmm. So, you know, some of the things that you can create, like I said, is you can, let's see, I have to remember looking at my notes here to see if I have an example of a VPA object. I don't, but I can find an example really quickly.
So
Yeah.
Emily says, I'd like to have GitOps manage everything other than resource requests and limits. And that's, I do want to hear an example if you do find one, because examples really help me form a mental model. But one thing I'm wondering is, are these likely to change? Like if you get if you have a request limit recommendation and you because you want to keep with GitOps principles and you don't want to have the VPA do it for you, and you manually change your objects to reflect these is that a good way to do it, or are they likely to change over time as people who use your application gets more and less use over time?
Yeah, so in general, so first of all, the recommendations are a starting point, right?
Okay.
If you're using Prometheus as the backend, they tend to be more accurate because Prometheus actually stores data. So VPA has a lot of historical data that it can go back and sort of see trends, whereas the metrics server doesn't actually store data. And so the VPA sort of has like an internal analysis thing that happens, but it doesn't necessarily capture the granularity that like Prometheus does, just because of the storage aspect. But once you set your beginning resource request and limits, you observe the behavior of your pods. For the most part, you can pretty much keep those as is. You would still want to throw, some other sort of fail safes in, right? So that's where you would want to have like a horizontal pod autoscaler and have that, or use Keta or something to do that, so that you can scale off of HTTP request, right? So you can create more pods. Because the difference is obviously it's the same as like a computer, right? You either add more computers to your stack to, account for increase in traffic, or you add more resources, but resources are finite. Um, and so it's a double sort of a double-edged thing, right? You have your pods using the amount of resources that are right for them, and you also have the ability to add more pods when you start to have traffic increase. So then, yeah, you can keep the same like resource request and limits in your GitOps, and then just scale your pods out as need be when you hit some, Black Friday spike or what have you, rather than going in and changing the size of your pods themselves.
So there's kind of two strategies. One is using VPA to actually make your resources and requests bigger, so you could have bigger pods.
Mm-hmm.
Is that, or
Yes.
you can use VPA to get a recommendation, set that recommendation in a permanent kind of GitOps way, and then use horizontal pod scaler to make more copies of your pod.
Yeah.
When is, like, what type of application lends itself to the vertical way, and what type of application lends itself to the horizontal way?
That's a good question. I think that things like batch jobs lend itself to the VPA auto update way, right? Because it can essentially use metrics from the last time the job ran to kind of, and batch jobs don't typically, I don't think, fluctuate that much. And so then it can use that as a means of always making sure that those pods have enough resources to run the batch job appropriately. Yeah, I think that's the best one for the auto update mode. And then for things like web servers, like web requests, so if you're running like Nginx servers, scaling out, so increasing the number of pods for something like that, I think is when you would probably want to use like an HPA.
Okay.
Yeah.
Did you have another one besides batch jobs?
For VPA? Let's see.
It's okay if not.
Yeah.
I'm asking for examples all over the place because I'm also still waiting for examples of flags.
Of flags, you said?
Yeah. I'm not. This is taking it.
Oh, I'm so sorry. Yeah. So the
it's
flags that you
Don't
could put.
apologize.
I mean, go back to the VPA. So the kinds of flags that you can put in to the definition of the VPA object are things like you can set a cap on how much CPU or memory the VPA is allowed to recommend, so a maximum, and you can set a minimum to say never go less than this amount in a recommendation.
Okay. Set resource and requests and limits on your resource requests.
Yeah, exactly.
Setter.
Exactly.
Great.
So you don't have someone, so the VPA doesn't come in and say, yeah, I think this like pod needs, 2
3
whole
nodes.
cores or something like that, right? Like if that's the case, you probably want to look at your application rather than let VPA just have its way with it. You can set flags for which containers within a pod the VPA will work with. So if you don't want all the containers within a pod to
okay,
have
if you have a service mesh running and you want it to ignore the proxy that it's put in your.
Yep.
I see.
Yep. You set the update policy, so that update mode we were talking about, auto initial recreate. That's another thing that you would set inside that spec for the VPA. Obviously, you have to tell it which workload to target.
Okay.
So those are a few.
I said set which containers to VPA. I made it a verb.
I like that.
Epic Tralala says, I need this. And the good thing, I have Prometheus data more than 1 year in history of all of my deployments.
Oh, wow.
So you can make good use of it right away.
Yeah, that's pretty much it. It's like as soon as VPA starts up, it'll have all that historic data that it can make. Because with the metric server, I think it's recommended that you have at least 8 days of data before
Ah,
uh, you start letting it make changes or whatever. But if you're using Prometheus,
uh-huh.
you have that much data, it's going to be more accurate faster.
Cool. And Emily says it seems like our Nginx pods have huge CPU spikes on startup. I think adding more pods would not help with
Mm.
that. So it could be a case for VPA, but we need to use GitOps too. GitOps as a requirement, you're saying, Emily? Um, so VPA could take over to make it big for the startup and then shrink it back down for what is needed for when it's actually running.
Right. Yeah. I mean, that sounds like a good use case for VPA. Or
Fascinating.
it could be, so this is one of those cases where you would based on, so the VPA would essentially take like that startup data, right, that spike, and it would also take like the regular running operation of that, and so it probably would make a recommendation that would not really help or account for that spike, right? And it depends on the spike that you have. Like if your spike is in CPU, um, so it's a controversial. There are two sort of sides on this, but some people think you should not set CPU limits, and that you should just set CPU request and then let your spiky workloads spike up a little bit, as opposed to throttling them, because the idea is that there could be excess capacity on the node for CPU, and if you don't let your workload like use that when it needs it, you're wasting CPU cycles. But there are other people who are very strongly in the camp of like you should always set limits for both of these things, to avoid the things we talked about with noisy neighbor stuff and resource contention. So I think that's going to be a matter of personal preference for you, because probably the VPA is not going to account for that huge Nginx spike when it makes your recommendation, right? But you could have it. You could have, and then what would happen, honestly, is you would start like your Nginx pod. It would have this big spike. VPA would be like, "Oh, you need more, resources for this thing." It would reschedule the pod, and then it would have more resources. But then once the spike went down, VPA would be like, "Oh, you're not using all these resources," and it'll reschedule the pod
Oh,
again, right?
and then
So
it needs them. Oh, in an
yes,
infinite loop.
yeah. So it's probably best to just give the Nginx pod a little more than it needs to account for that spike
Yeah.
in this case.
And then that works with the GitOps requirement too.
Exactly.
Then.
Yeah.
Interesting. If anyone else in chat has experience with that, please do chime in. I'm
Yeah.
interested to hear whether you just like let spikes be spikes, or if there are ways to minimize your spikes, or
Yeah. 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 If you,
So,
sorry, go ahead.
yeah. Oh,
I
no,
was just gonna
I
say,
would
if
like
you
you to
have like
finish that.
consistent, if you have spikes that happen a lot, then you might want you'll want to address that. But like if it's like one initial spike, yeah, I would probably just set the resource to be such that it accommodates that spike. And I've seen
Yeah.
workloads that do that. So yeah.
Yeah. Emily says they have huge CPU spikes on startup. So it seems like it does feel like wasted if resources if you're running it all the time to accommodate that huge spike.
Well, the SRE says that if you have huge spikes in startup with Nginx, I would be curious as to what Nginx is doing at startup that causes those spikes, and seeing if there's a way to mitigate that part.
Mm-hmm. Okay, so back to Goldilocks. I'm getting a great idea of what vertical pod autoscaler does, and now I'm trying to figure out. So we have VPA, and from the Goldilocks perspective, we're not even necessarily using the updater and admission controller part, except so Goldilocks is a visualizer, and it visualizes the stuff that the VPA recommends.
Mm-hmm.
But then you can manually make changes, which is good for GitOps, or Goldilocks can make this vertical pod autoscaler objects, which allows you to set flags for how you want VPA to work. So it sounds like this vertical pod autoscaler object is giving vertical pod autoscaler permission to use the updater and the admission controller part of vertical pod autoscaler.
It can, but it doesn't have to, right? So you can, so when you install Goldilocks, if you install the VPA as part of the Goldilocks chart, so Goldilocks will only install the recommender portion of VPA, right? It doesn't install the admission controller or the updater. And so what happens is you decide what workloads you want the VPA to make recommendations for. And then you can tell Goldilocks that information in a couple of ways. You can either label a namespace, which will make all the workloads in that namespace get a VPA object. You can, in the Goldilocks chart, specify all namespaces. So like defaults to all namespaces. And then you can also exclude namespaces. So that's how, so Goldilocks uses namespace labeling as a way to determine which workloads are going to get VPAs created.
There's something I don't quite understand about what's happening.
Okay.
If you're not using the object to have it do its whole thing, then what's the point of making the object?
Because the recommender, it still creates, so the object has the spec and the status. So I might not be being clear about Goldilocks creating the vertical pod autoscaler object. So the vertical pod autoscaler object, Goldilocks will create it and it will set some of those flags for you. So like the update mode, it'll set to, disabled by default for Goldilocks. And I believe Goldilocks will let you pass in flags that specify some of those other flags in the VPA, right? It's kind of like, essentially like Goldilocks is taking the details and burden of you going in and creating a VPA object for each thing that you want the VPA to recommend for, and it's doing it for you. And then you can tell Goldilocks in its configuration some things that you want to have in that VPA object, right? So like I said, the min and max allowed thing, how what update mode it's set to and stuff like that. And then Goldilocks creates that VPA object for you. And then the VPA, the recommender, uses that VPA object to both determine what workloads to make recommendations for and the parameters to use for making those recommendations.
Okay.
Does that make sense?
It makes sense. But it still seems to me like these VPA objects, you're counting on them to do the work of the scaling.
Well, you're not. You mean in which way? Like in the auto update mode? Because there's no scaling happening without those other two components, without the emission controller and the updater, right?
Right.
So you're literally using the vertical pod autoscaler to inform the recommender when it makes its recommendations. And then the recommender is also using that VPA object to then store its recommendations.
Okay. VPA informs recommender.
The VPA object, you might want to specify.
Thank you.
Yeah.
I want to say like shapes what recommender recommends.
I think that's good wording. I like that.
Recommender's recommendations. And then you use Goldilocks uses namespace labels. Will you help me with that part?
Yeah. So it uses namespace labels to determine which workloads to create the VPA objects for.
Okay. To cool. So without Goldilocks in the picture,
Mm-hmm.
without Goldilocks in the picture, if I was just trying to use VPA, first of all, I have no visualizer. I'm kind of like using kubectl or whatever to try to figure out, okay, I know there's a recommendation here somewhere. Let me find the right vertical pod autoscaler object that has it, and then like,
Yes.
okay, but what did I set? What also the flags are here. And so then like at scale, when you have tons of workloads, you're like having to consult this granular text-based object to try to figure out, like, did I remember to say just the particular workload, or do I have it set to the whole pod, and like which namespace is it for? And it's all here, and it can be hard to keep track of it all. So we have just like a visualizer that just, first of all, just helps you make sense of it.
Yes.
But then in the visualizer, you can also set some like global opinions that you want to have across your organization, which is something you can't do directly with the VPA. And so then with Goldilocks, you can make it easy to see what the recommender says. But then when you can control what the recommender recommends with your VPA objects. And some of those flags can be set to default global, what your organization wants you to have, because you've done that in Goldilocks when the Goldilocks makes the VPA objects.
So I want to be clear about this concept of a global setting, because it is actually very much per workload per namespace, right?
Okay.
So there's no overarching configuration, and in fact, there is no configuration that happens in the Goldilocks UI. All the configuration that you do is when you deploy the Helm chart, right? So you, in your values YAML file, you set the things like, whether you want it to be on for all namespaces. And then for each one of those, you can set some flags as well. So you can say whether or not you want a namespace to be in update mode auto, if you want to turn that on, or if you want it to be enabled, or if you want update mode auto for a specific workload within a namespace. Those are all things that you can put in your VPA. But Goldilocks is ultimately responsible for, one, creating a VPA object that the vertical pod autoscaler can use when it makes its recommendations, which the recommender also reports its recommendations to, right? So Goldilocks creates the VPA object, and then it also reads the status from the VPA object and displays it in the dashboard for you. So you can easily see, here's what we recommend you set your resource request to and what your limits to, and this is what this would look for this quality of service, and this is what it would look like for this other quality of service.
Okay. And so you can also see, like, for different workloads, like different types of workloads running in the same namespace, you can see what their different settings are.
Exactly.
Compare them to each other.
Yeah. So instead of having
setting global, but you at least have context of what else is happening at the same time.
Yeah.
Okay.
And as you said earlier, like if you have like a large cluster or a lot of workloads, can be a pain and not realistic to have to go in and cube control you know, each different workload to be like, what did the VPA say I should do? Um,
So I think to help me finish, like help me create my mental model around Goldilocks, what's going to help me with the last of this board, if it's okay with you, you can see that I'm writing benefits of
Yeah.
Goldilocks. I think it'll help me because we're talking all around it. I think it'd be help me to write down like exactly like these are the benefits. This is why it's better than standalone vertical pod autoscaler. Let's just list them out.
Yeah. So easier visibility into the recommendations. So no kubectl.
Into VPA recommendations, is that?
Yeah.
Excellent.
And then easier creation of VPA objects.
Cool.
And that means no manual, YAML manifest, which is good.
Yes.
Yeah.
Okay.
And I'm gonna say those are probably the two biggest benefits that I could think of. It's for the end user, you know.
What about showing the context of the one particular workload's requests and limits compared in like choices you've made of flags in vertical pod autoscaler?
I'm not sure. So say more about that.
Oh yeah. So you have opinions in a vertical pod autoscaler object, and you have performance around a certain workload, but they're different types of workloads running in your cluster.
Yes.
So it seems to me, just hypothetically, having first learned about all this today, that seeing what one pod is doing, what one workload's doing, and how it's performing, and how everything's set will help you determine what you want to do for a second workload or a totally different workload that's also running in your cluster.
Yeah, I mean, I suppose that could be a benefit. That could be listed as a benefit, right? If you are able to easily visualize, if you have sort of similar workloads, right, and you're able to visualize what that workload is operating at, what the recommendations are for it, then that can help you out of the gate have a more realistic and performant requests and limits for a similar workload.
What? Okay. Yeah, like two different web apps. Does Goldilocks supply recommendations for how, like initial ways to set up VPA?
The documentation does not. So if you, like I said, if you install the VPA via our subchart, then we are opinionated in how you set up VPA, and that stuff is obviously set up that way, right? So it will work out of the box with the way that Fairwinds thinks you should have VPA set up to work with Goldilocks. If you install VPA on its own, so if you use their script from their repo, then the documentation doesn't actually say much about how to set up VPA other than telling you that you should not put it in auto update mode.
Okay.
Warning you that that you should not start off that way, for sure.
Great. This is cool. I've learned so much.
I think one other thing that we touched on that is a benefit of Goldilocks, but we haven't gone into much detail about it. And I see we're short on board space, so I'm not going to give it too much. But there's a concept of quality of service when
Yeah.
you make resource requests and limits, right?
Uh-huh.
And the other thing that Goldilocks does is that the resource requests and limits that it exposes to you in the dashboard are
Mm-hmm.
grouped into quality of service categories. So it tells you what it recommends the resource requests and limits are if you want a guaranteed quality of service or if you want a burstable quality of service, which is also handy, I think.
Guaranteed or burstable. Those burstable is a colorful word.
It is very
Uh
colorful.
and I can infer what that means. Like
Mm-hmm.
this workload is guaranteed to get the requests that it asks for. And this one, it's a bubble. I just blew a wand of bubbles, and it's one of the bubbles, and we'll see how it does.
Yeah.
It's a burst. We have what we want, but if it doesn't get that, it's no big deal. Um, and so with quality of service, how does that relate to our benefits, please?
So it just shows you the settings for each type of quality of service. So you get to choose when you're applying these in your GitOps, for example, what matters to you. If you have a workload that you want to absolutely get this
Mm-hmm.
amount of CPU and memory every
Mm-hmm.
time, then you want guaranteed. And so Goldilocks is going to show you to get guaranteed, you essentially set your requests and limits to be the same amount. So, and Goldilocks will show you that recommendation for guaranteed. And then it'll also show you what you would need to set if you're okay with a burstable QoS, which means that the request is less than the limit and it allows your workload to like spike up a little bit and use a little bit more than it requests, or however a lot more. Some people set their limits really high. It's not a good thing. Don't do it, but some people do.
I want to do a lot of work to set it and be inefficient about it. That's what I want. Guaranteed or burstable quality of service. So basically, it helps you set your quality of service.
Yeah. So going back to the question about Nginx, actually, I think this sort of fits in perfectly, right? Because you would probably want to have a burstable quality of service for your Nginx pods, and you'd want to set your request to be like the baseline that Nginx needs to just perform, because that is used by the scheduler to determine what node to put it on. And then you can set a limit that's higher than that allows Nginx to burst up, but not go beyond that limit.
Used by squat. Did you say burst up?
I did.
I love it. I want a T-shirt that says "burst up."
Burst up.
Yeah, it's
Very
like
inspirational.
Fail forward, right? Burst up.
Burst up. Oh.
Burst up. Okay. I'm glad we talked about that. Yeah. And Emily, thank you for your kind words. Emily says, thank you. Good to know that Nginx and startup doesn't necessarily need to have the huge spikes.
Oh, yeah.
Yeah. And then Ganatak is here. Hello, Ganatak. Welcome. I'm glad you were able to join today, friend. Cool. So do you feel like there's anything we need to add? I can write some here. I can find some little spots here and there if there's anything you feel is missing from the board.
I'm like, I see your little face just like in this very small space. I was like, I don't want to cover. No, I mean, I think I feel like we covered in a very roundabout way, and that's totally on me because I clearly I ramble also. But I think we've covered the basics of Goldilocks and how it works, right? So vertical pod autoscaler is is a long-lived, very popular, very standard add-on to a cluster. And Goldilocks makes use of its functionality um, by making it easier for users to use it. Honestly, it's kind of like Keta, right? Because Keta does a similar thing. Like Keta creates HPAs for you. So it makes it so that you don't have to go in and manually create an HPA for every workload that you want to scale. Goldilocks does the same thing with VPAs. It makes it so that you don't have to manually go in and create a VPA for every object that you want to scale vertically.
Ah, that's a nice. CADA stands for Kubernetes Event-Driven Autoscaler.
Right.
VPA has 3 parts, and then we talked about 4 parts. I'm going to skip that. And then I like that analogy. Like Goldilocks is to VPA what CADA is to event-driven autoscaling.
Yes.
I
Yeah.
don't think I have space for that, but we'll say it to each other.
But we know
twice.
it. Yes. We know that.
All right. So what I'm going to recap everything that you just taught me over this past hour, and together we'll make sure that there's a clear understanding that's happening. And
Okay.
if along the way I say something wrong, or it could just be clarified, feel free to interrupt me, and we can fix up the board. Okay. So we started talking about way back before Goldilocks, so more than 5 years ago. Kubernetes requests and limits were underutilized and or misused. So they might be not being set at all, or maybe they're being set incorrectly. We talked about if you set them for too little, then your resources are going to underperform because they don't have what they need. But if you make them too big, there's wasted space on nodes, or you're also giving, like, if something has a memory leak, it's actually going to take real resources away from your cluster if that happens. So we call it the noisy neighbor problem, when one resource is using more than what it needs. And more colorfully, we said before something like Goldilocks, the resources, they would fight it out, which so there'd be resource contention and instability. And you don't have, like with Kubernetes, the whole point is you're declaring the state you want things to be in. But then if there's not the resources you want, then that actual state can't come to be. So you don't have the predictability of the actual state achieving the actual state that you defined. And then there's also the matter of just the sheer expense of wasted infrastructure. So now Goldilocks and Vertical Pod Autoscaler together, they're holding hands and wearing superhero capes and coming onto the scene. So before I even talk about Goldilocks, well, I'll say Goldilocks is a visualizer for Kubernetes resource requests and limits. But what is key to understanding Goldilocks and making Goldilocks work is the Vertical Pod Autoscaler. So Goldilocks especially interacts with the recommender part. So the Vertical Pod Autoscaler has 4 parts. We have the recommender, which takes metrics and uses them to make requests and limits recommendations. And I'm going to say it takes, for one thing, metrics could be like metric server or Prometheus.
Correct.
But for another thing, it sounds like it's not only metrics it's also taking what you've defined in a Vertical Pod Autoscaler object. So the Vertical Pod Autoscaler object is telling you what object do you want recommendations about. And so it's showing you and then you're setting flags about like requests and limits on the amount of requests and limits on the recommended requests and limits, which turtles all the way down. And it also is showing you the current recommendation, but you can set flags for what you want. So the recommender is like, okay, based on the flags defined in the Vertical Pod Autoscaler object, and like what also, I'm also looking at the object defined in the Vertical Pod Autoscaler object. And I'm taking metrics, and altogether I'm using that, and I'm spitting out some request and limit recommendations. Now, if you want, you could use these other 2 resources too, but Goldilocks does not. And that's the updater that basically it takes those recommendations made by the recommender and it acts on those recommendations. So it's going to evict pods that fall out of the range of the CPU and memory recommendations set. An admission controller also takes action on what the recommender does, and it mutates new pods that enter the cluster and sets requests and limits based on what the recommender recommends. The difficulty here, and there is no right answer. Some people are going to decide this is better to use something that automates it. Other people are going to decide here's the thing. VPA can fight with GitOps because if you have something different declared in your Git repository and your GitOps tool is trying to make what you have declaratively defined, make it active in your cluster, and meanwhile VPA is also trying to change what's happening in your cluster, then those two might fight. And also vertical pod autoscaler can similarly fight with horizontal pod autoscaler, which is also trying to make changes about how things are being scaled in the cluster. So if you are going to do things with the updater and admission controller where you're letting actions happen in your cluster based on the recommendations, be aware that it needs to be able to integrate with other tooling. So that's the vertical pod autoscaler. So now we have Goldilocks. So Goldilocks provides a like a dashboard to be able to see what's being recommended currently, right? And so that can be hard to navigate with kubectl and with having to find and view lots of different vertical pod autoscaler objects for lots of different, you presumably have a lot of different types of workloads running in your cluster and one of these objects for each one. So we have a nice central place where we can view what our most updated recommendations are. And then you can, based on those recommendations, you can manually make changes in the case of, say, GitOps, or you can also use Goldilocks to make VPA objects to set further flags on how you want VPA to make recommendations. So those vertical pod autoscaler objects can have your opinions. And those examples of those opinions are min and max allowed resources, which resources we're looking at, like which containers in the pod, or both containers, or no containers. Well, that would be silly. But, or whether update mode is on, and update mode is when you're actually taking action. So you can turn that on with Goldilocks' help, or in general, just within the vertical pod autoscaler. Goldilocks will use namespace labels to determine which workloads to create VPA workloads for. And the vertical pod autoscaler object shapes a recommender's recommendations. So Goldilocks, it's deployed as a Helm chart, and it's run as a controller and a set of CRDs. And it has these benefits. So we have easier visibility into what VPA is recommending. You don't need kubectl. It has easier creation of VPA objects. So you don't have to do the manual manifest. It has an interface for your VPA objects. I came up with this one, so maybe it's less official, but I think it would be helpful to have context about what similar workloads that are similar to yours are doing in terms of their vertical pod autoscaler. So when you create yours, you have an idea of where to start, and that could be shown in Goldilocks. And then Goldilocks also shows you what you need to get the right quality of service that you want. And quality of service, there can be guaranteed, where you 100%, like the scheduler is going to do whatever it takes to make sure you get the resources that you request. Or there's a burstable where the scheduler's like, yeah, I'll try, but if it doesn't work out, I'm not too worried about it. And so Goldilocks can help you set that up to be what you need and want it to be for any particular workload. Did I miss anything? Does anything need further elaboration?
No, I think that was really concise. You did better than I did explaining it in the end. Yeah, I just want to be clear on first that. So yeah, in the case of if you're using Goldilocks creates the VPAs for you, full stop, right? So if you say Goldilocks, if you label your namespace as such, or you enable the flag that says on by default, Goldilocks, for every workload you deploy to your cluster, Goldilocks will create a VPA for that workload in that namespace, right? So you are hands off with VPA creation at that point. You can control flags for the VPA creation in the Helm chart, but you were at that point, Goldilocks is doing your VPA creation for you. As we said, Goldilocks is to VPA as Keta is to HPA, right? It controls, it makes those things for you. And then I just want to make sure we clarify it. So with burstable workloads, you get the request that you set is what's used by the scheduler to make sure to put it on a node. And so you are guaranteed to have that amount of resource used available on that node when that workload is scheduled. And then the limit essentially means that, like, at that point, your workload, your pod can start to use more CPU or memory than you requested up to a limit. And if you hit that limit, then your pod will be or your container will be killed. Or if it's a CPU limit, your CPU will be throttled. So it essentially, it's less of a like, I'm kind of sort of guaranteeing, and more of a like, I'm guaranteeing your starting point. And if you go up, you can go up from there a little bit, but there's a cap on it. And so that's what the difference between the guaranteed and the burstable QoS, which Goldilocks will show you both settings.
Okay.
Yeah.
Thank you for that.
Mm-hmm.
So you set, upon your installation of Goldilocks, you're setting your what you want your VPA settings to be, and then Goldilocks makes the VPA objects for you, so you never make them yourself.
Yes,
Goldilocks
exactly.
is helping from that. Full stop.
Exactly. Yes.
I'm going to just I just casually wrote this thing that ends up being a big point. Goldilocks makes VPA objects. I'm going to just point a lot of arrows at it to show that it's... I'll also give it an exclamation point, maybe 3. There's room.
Oof, wow.
Yeah, that's how we know. This is
strong.
Yeah. Emily says, great session. Appreciate both of you. Thank you so much for being here, Emily, and for asking questions. That makes it a better show for everyone.
Thank you.
And is there anything else you would like to add or want me to capture on the board?
No, I think we did great.
Yeah, that's what I want to hear. Then I'm going to say goodbye. So first, thank you to Stevie for coming on the show and sharing your time and your expertise with us.
Thank you.
And thanks everyone in the chat for being here and asking great questions. And thanks to everyone who watches the recording later. Appreciate you. Bye. Yeah, Stevie, bring it. Bye.